Hello guys, today we will learn about limiting reactant and percentage yield. In this reaction we have salicylic acid, acetic anhydride, acetyl salicylic acid, which is the aspirin, and acetic acid over there. That's our reaction that occurs in order to produce aspirin. This is the product that we care about for this problem. So I will read you the example. Aspirin is synthesized by the reaction of salicylic acid and acetic anhydride. That reaction produces aspirin and acetic acid. Now the question is, what mass in grams of aspirin is formed? And the exercise gives you 20 grams of salicylic acid and also 20 grams of acetic anhydride. As a first step, I always suggest to check, is it balanced? To know if it's balanced, we need to compare how many elements do we have in both sides of the reaction. We have carbon, hydrogen, and oxygen, a chill reaction as usual. So let's count. Carbon, we have 7 and 4 makes 11. Hydrogen, we have 6 and 6 makes 12. And oxygen, we have 3 and 3, that makes 6. Now let's see the products. In the products we have 9 carbon and 2, which is 11. Hydrogen, we have 8 and 4, that makes 12. And oxygen, we have 4 and 2, that makes 6. So if we compare each of the elements, we can conclude that yes, it's balanced. Now, the second step is, as we do in limiting reactant, we always compare the product of each reactant. So here we have one reactant and our second reactant. So we're going to compare what is the product that produces each reactant. The first that we have here is salicylic acid. I will abbreviate the salicylic acid as SA. So we have 20 grams of salicylic acid. Okay. Now the idea of this problem is you have mole given. No, you don't have mole given, you have grams given. Oh my god. You have grams given. So from grams, what can you get? You can get moles. From grams to moles, we're going to use molar mass. In this case, we start with the given, so it's going to be the molar mass of the given. Now, from grams to mole, then when we have moles to mole, we're going to get the moles unknown. And when you have the moles unknown, you're going to use the grams unknown. So from mole to mole we use molar ratio, and from mole to grams we use the molar mass, but in this case will be the unknown. Which one is the unknown? We already said it's aspirin. So let's start. 20 grams of salicylic acid, Now, salicylic acid is made of 7 carbon, 6 hydrogen, and 3 oxygen. So you already know how to calculate the molar mass. And we say grams in the top, so you're going to write the grams in the bottom. Grams of what? Of the salicylic acid. I know I said salicylic acid, don't bother. Now, we have 7 carbon, which is 12.011, plus 6 hydrogen, which is 1.0079, and we have 3 times 15,999 from oxygen. The molar mass is 138.12 grams inside what? 1 mole of the same substance. Now, we already used the molar mass, now we're going to use the molar ratio. Molar ratio between what? The unknown and the given. So, the given is salicylic acid, the unknown is aspirin, so the given, you're going to write it in the bottom in order to cancel. So you're going to write 1 mole of salicylic acid gives you how many aspirins? Well, how much aspirin in total? As we don't see any coefficient, we could say that everyone has a coefficient of 1. So this is going to be the molar ratio, 1 mole of aspirin. And then, in the last step, you're going to get the molar mass of the unknown. So in what way we're going to write it? Moles in the bottom in order to cancel. 1 mole aspirin that has, okay, aspirin has 9 carbon plus 8 hydrogens plus 4 oxygens. That gives you a molar mass of 100.73. Oh, I should have done something wrong. Let me see. 0, 0, 0, 0. I found it. It is 180.15 or 16. 180.16 grams of aspirin. So here we can cancel all those units that we don't need anymore. Grams of salicylic acid with grams of salicylic acid, moles of the same substance, moles of the same substance, moles of aspirin with mole aspirin, and the final answer will be remember, everything in the top will be multiplied, everything in the bottom will be divided. So we're going to have 20 times 1 times 1 times 180.16 divided by 138.12. So this will give you 26.09 grams of aspirin. Okay. That's the first reactant. Now we're going to see how much aspirin will be produced from acetic anhydride. So you have the grams are same, 20. 20 grams of acetic anhydride times. Okay, the first step is the same pattern, okay? Gram to mole, mole to mole unknown, and mole unknown to grams unknown. So first of all, we're gonna need the molar mass of the acetic anhydride. So we have 4 carbon plus 6 hydrogen plus 3 oxygen. Remember to keep the calculator with you. So the molar mass gave us 102.09. I'm gonna see if I didn't commit any mistake. Okay, 102.09 grams of acetic anhydride that are inside 1 mole of the same substance times. Okay, from mole to molar mass, we're going to use molar ratio between the given and the unknown, which is aspirin. So we have 1 mole. Remember, 1. If you don't see it, it's 1, 1, 1, 1, 1, and it was balanced. So 1 mole of acetic anhydride produces 1 mole of aspirin. And then, in the final step, the molar mass of the unknown, as the unknown is the same substance, which is the aspirin. We already got the molar mass from the step before, that is 180.16 grams of the same aspirin substance. Remember to cancel these units that you don't need anymore. Grams and grams of acetic anhydride, moles and moles of acetic anhydride, moles and moles of aspirin. And you perform the calculations here with your calculator. 20 times 180.16 divided by 102.09. Everything in the top will be multiplied, everything in the bottom will be divided. So the answer is 35.29 grams of aspirin. Now, by definition, the limiting reactant is a reactant that limits the amount of product. In this case, the product that we care the most is aspirin. Now, from the two of them, which one produces the least? As you can see, 26 is less than 35. We say that the limiting reactant is the one that produces the least. In this case, what is that reactant? Salicylic acid. So this one is going to be the limiting reactant. In conclusion, the limiting reactant is salicylic acid, and the product is 26.09 grams of aspirin. That was the last topic that we actually saw. But now we're gonna continue with percentage yield. As this is the limiting reactant, this is the total amount of aspirin that will be produced after the reaction. Remember the example that we discussed in class about the hamburgers. Remember, it doesn't matter how many cheese you have. It doesn't matter if you have 100 buns. It's at the end, you just have 4 meats. At the end, you will be able to produce only 4 hamburgers. Now, in this case, the only product that will be possible from this reaction is 26 grams of aspirin. Now, imagine that we are in a lab and we make salicylic acid and acetic anhydride react. In real life, under real conditions, we're never going to get 26.09 grams. Not even 26, no more than 26. We're always going to get less. And that is because in real life we have many conditions that may affect the result of a chemical reaction. That's why we're going to introduce the new topic, which is percentage yield. To talk about percentage yield, we're gonna first of all define the formula. Percentage yield is, as you can see, it's just a percentage that says actual yield divided by theoretical yield times 100. Now, how can you tell which one is the actual and which one is the theoretical yield? Let's say in the lab, let's say we have a lab right here next to me, And after I did the reaction, after I made the salicylic acid and the acetic anhydride react, in real life, I just got 23 grams of aspirin. And you might be wondering, this is what we really got, okay? Now, in theory, what we got on paper, the theory told us that we should be able to get 26.09 grams of aspirin. So, what you have in reality is what we're going to get, or we're going to know as the actual yield. The reality is what we obtain in the lab. And the theory, or the theoretical yield, will be the one that you obtain in paper, okay, after a bunch of calculations. And you might be thinking, what if we are doing a mathematical procedure? We're going to tell that that's theory, okay, that's in theory. Not because you are applying or you are learning just theory. No, that's what you actually do in numbers. The theory in this case will be all the calculations that you do in paper. And we're going to tell this as the theoretical yield. So the lab is the actual yield. And the theory, what you got from the limiting reactant, tells you the theoretical yield. Now, from knowing this, let's apply the formula. Let's apply the formula, and let's get the percentage yield of the reaction that we just did. So we say percentage yield equals the actual yield is what I got in the lab. And I got in the lab 23 grams. The theoretical yield is what I did from the limiting reactant. What I got from limiting reactant was 26.09 grams of aspirin. Now, if we're talking about a percentage, we're going to multiply times 100. Everything at the top will be divided, everything in the bottom will be everything at the top will be multiplied, and everything in the bottom will be divided. So, let's perform the calculation here, and you'll get 88.16%.